Now, in this last part of this lecture, what we are going to do is we are going to talk about arrays. So, again the idea of the array is, if you have a set of numbers which are similar type or which contains similar type of informations, then instead of defining a variable for each of the numbers, I can set them in a form of a array by using just a one variable type. So, by definition, an array is an ordered sequence of many instances of the same data type. So, for example, you can think of that you need to write a vector. Okay. So, a vector has three components x, y and z. So, you can do it in two ways. So, you can declare, say for example, V1 as one variable, V2 as one variable, V3 as another variable. So, each contains each component of a vector. So, basically what you are doing, you are using up three variables here, but the same thing you can store using just one variable, say I call it as V, and I declare it as an array containing three numbers. So, this is what the idea of using an array is. So, it stores the same information, it stores all the individual components of a vector, but now I use just one variable instead of three variables here. Okay. So, similarly, same thing also applies when we try to store matrix, say for example, a 3 cross 3 matrix. Okay. So, the way one uses this is, so basically array has one needs to mention two things. One is what type of data you are storing in that array, that is given by this data type. Then you need to also specify the dimension of the array, which is done by using this dimension keyword in the Fortran, and then you define give the variable name. So, one thing you note is that the ID this contains the dimensions, okay, and the dimensions you can either. So, basically what it is it's a comma separated list describing the index range in each dimension. So, here is so what I mean to say is, suppose I want to store a 3 cross 3 matrix. So, I define the matrix by M. So, now I have to give 3. So, the way I will declare that array is M3 3. Okay. So, what it means is that along one direction I have 3 elements and along the other direction I have 3 elements. Now, this if I write it this way, so what the code will assume is that the counter on 3 goes to 1 2 3, and similarly for this it will also go to 1 2 3. So, instead what I can also do is, if I want to go this index from 0 to 2, I can write it as M equals to 0 colon 2 comma 0 colon 2 in this fashion. So, what it means is that basically, so this one has 3 numbers, that is M is my upper one, N is my lower one. So, M minus N, 2 minus 0 is 1 is 2 plus 1. So, that tells me 3 numbers, and similarly in this way. So, the number of values stored in this part is 3 in this example and 3 in this example. So, here are some examples in which one can declare variables. So, for example, here I have declared an array which I am calling V1, which has a dimension 5, and it is a real type of array. Similarly, now in this case the indices will be going from 1 to 5, but I do not want to do that. I want to declare an array with the indices -1, 0, 1 and 2. So, then I change this part of my declaration in this fashion. So, I give a lower limit which starts from -1 and upper limit which starts from 2, and going by the previous formula. So, 2 minus -1 plus 1, this will give me 4. Similarly, I can declare, I want to declare 2 cross 2 array of integer numbers. So, where the indices go from 1 to 2 in along each direction. So, I do it in this fashion. So, there are some terminologies which is associated with arrays. So, let us look at these and let us start with this particular example. So, here I have in this line I have two array declarations. One is given by A, which has just one set of indices which goes from 0 to 100, and another given by B, which has three sets of indices which each of which goes from 1 to 5. Now, so one important thing about the array is called the rank of the array, which tells us how many dimensions are present in the array. For example, for case A, the rank will be just 1 because it has just one dimension. In contrast, for B, the rank will be 3 because it has 3 dimensions. Then there is something called the bounds of an array, which tells us the lower and the upper limits of the array along each dimension. So, for example, for A, the bound will be 0 to 100, while for B, along each dimension, the bound is 1 to 5. Now, the dimensions extent tells us how many elements are present along that particular dimension, and this is given by the formula, which is the upper bound minus the lower bound plus 1. So, for this particular array, so the number of dimensions will be 101, 100 plus 0 plus 1, and while for the array B, each dimension has an extent of 5. Then another thing is another terminology to characterize an array is its size. So, size is basically contains the total, tells us how many elements are there in the array. So, for example, here array A has 101 elements, array B along each dimension has 5 elements. So, you can think of a 3-dimensional array as a cube in which the numbers are arranged in a cubic fashion. So, a cube, so 5 into, so each dimension has 5. So, 5 into 5 into 5. So, total 125 elements are present in the array. Then there is something called the shape, and a shape of an array is defined by its rank and extent. So, for example, A has a shape 101 and B has a shape 555, and like matrices, so arrays also needs to be conformable. So, arrays are conformable when they have the similar shape. Now, how does one access an element in an array? So, that is done by its subscript values. So, we access a particular element of an array using the subscript values. So, for example, to assign a variable x the value in to the value in the mth row and the nth column of a matrix A, we could use a statement like this. So, basically what this statement means is that in the matrix element A, in the mth row and the nth column. So, suppose if I have a 3 cross 3 matrix and I write A, I consider A as 2 and 3. So, I have a 3 cross 3 matrix containing say 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, and now I want to pick up this particular element and assign it to this variable x. So, what it means is that I go to the mth, the program will go to the mth row, that is m here is 2. So, I go to the second row, and from here and the column I go to the third column. So, basically this is the element that will go to x. So, these numbers m and n, these are called the index specifier of an array, and one should be careful that the arrays, the index specifier should lie within the ranges given in the declaration. Finally, one can also use sub array by specifying a certain range along a particular dimension as given in the declaration. So, this is an example of a code which assign an array. For example, I have here declared a variable which is an array which 5 elements in a particular dimension, and like one way I can do the assignment is in this fashion. So, I by hand assign each of the elements of the array. So, here say for example, this will be V1, 1, this will be V1 2, and so on and so forth, and this will be V3 5 element of the array. But if you have, I mean, this type of assignment is feasible only when you have a few numbers. But if you have, say, an array in which you store a million numbers, okay, then one can't do the assignment in this way, and then one needs to find an automated way to generate the values or assign the values into the individual elements of an array. And this can be done in the following way. So, in this case, what we have done is we have used a do statement. So, I have 5 elements in the array. So, the counter in my do loop goes from I equals to 1 to 5, and then for each index of the array, I assign the value given by this mathematical operation. And then once this assignment is done, here I am printing the output on the screen. So, what you can do is you can try out this program and try to see how the output is done and try to understand how the assignment is done. So far the last example was assigning an array which contains a vector. Now, in this example we will assign an array which contains a matrix. So, now for the matrix we have 2 dimensions present here. So, basically to do an automated assignment we need to have 2 do loops. So, that is why I have used a nested do loop here. So, do I equals to 1 to 2, do j equals to 1 to 2, and then the matrix element will be assigned in this fashion. So, this what it will do is it will, each time this loop is executed, it will assign all the values, it will assign this value to all the matrix elements. If you want to assign different values, then you can write this in this fashion: matrix j comma I equals to I plus 1 plus I plus I plus j minus 2. So, this the way I mean writing it in this way, it will assign a different values to each of the elements. Otherwise, if we had written it in this fashion, then every time this statement is executed, what would have happened is all the elements of the matrix would have been reassigned with the new value of this expression. So, one can do also operations which one can, instead of using a do loop, one can, if one tries to do the same operation on all the elements of the array, one can also do that. For example, suppose here I have 3 arrays V1, V2 and V3. So, what I want to do is, so my V2 and V3, I know what are the array elements, and I want to set in my, I want to create a new array V1 in which each element of this new array contains the sign of the corresponding element in the array V2 plus the exponential of the corresponding array in V3. So, basically what I mean is, suppose if I am looking at V say 40, the 40th element in the array V, this would be sign of the 40th element in array V2 plus the exponent of the 40th element in the array V3. So, one way to do that is I execute a do loop, do I equals to say 1 to 50 and do, then my V I will be sign V1 I plus exponential V2 I. So, this is one way to do it, but you can do it in a much more sophisticated way. So, all these 3 sets of instructions you can directly replace by this one single line. So, basically what it means is you can, I mean, just by using this one expression, you can do these same operations on all the elements of the array at one shot. So, similarly thing also applies for a logical array if you have one. Apart from these, there are some array intrinsic functions. Suppose if you are interested to know the sum of all the elements present in an array X. So, what one can do is one can use this sum variable. So, what this sum variable will do is it will take each of the individual elements of the array and then gradually and then add them up, and in the output it will return the sum of them numbers. Similarly, you can use product to compute the product of the number of the all the individual elements of that array. you can compute use the function called transpose, which will compute basically which will redefine your array elements in this form. So, x ith and x ijth element will be assigned to the x jith one. It is the same concept like a transpose in a matrix. If you have two vectors which are stored in an array, you can use some function called the dot underscore product, which will give you the number, which will return a number which contains the vector product. You can also do multiplications between two matrices or two arrays in using this matmul intrinsic function, but one should be careful that the second dimension of x. So, these two should be matching, the second dimension and the first of x and the first dimension of y. So, this is sort of again similar to my vector algebra. So, here we have some simple examples of input output arrays. So, you can include input output the arrays in your input output statements also. So, for example, here you have in this example you have an array 1 whose dimensions are given by these two numbers, and then you read the element in this fashion. So, the first element is assigned with the indices 1 1, the second element is 2 1, 3 1, so on and so forth. Now, often it is what so far we have seen is that whenever we have an array, so we need to know a priori that what are the dimensions of the array, but many cases it may not be possible. Okay. So, what does one do in those cases? So, in those cases what one uses a different type of arrays which are called allocatable arrays. Okay. So, what the allocatable arrays does or allows you to do is that it allows you to dynamically allocate or reserve memory to store a set of numbers in an array and then also deallocate it. So, basically it consists of three keywords. First one is allocatable, the second where. So, this part comes in the declaration part, then this part, this allocate, comes in the program where you basically in the main program, main part of the body, where you allocate the variable dimensions to the particular array which you have declared as allocatable. And then once you are done using the data of that which is stored in that array and you do not want to use it or use that data again, then what you can do is you can deallocate the array. So, let us see how one does that. So, for example, here I have program where I am trying to allocate some values to a vector, but suppose I do not know what is the size of a vector. So, what I will do is if I had known the size of the vector, I would have put a number to this dimension, okay, indicating the range. But since I do not know it, I put colon here in this line and I use this allocatable statement to tell the compiler that at present I do not know what is the size of this vector. Okay. So, the thing which I want to do is I want the user to determine the size of this vector. So, suppose so in order to do so, I put in a print statement here which I say enter the size of the array. So, when the user sees this while running the program, then he or she will write some number which will the value of which will determine what is the dimension of my array. So, this is stored in the value n. So, then I use the allocate attribute in my program and I assign the vector to have the dimension of n. So, once this is done, so then now what I can do is I can use for example, as I have done here, I use a do loop and assign to each element of of this array the following variable. Okay. So, once I am done, I want to give to the user the values which has been generated and stored in this variable vec. So, I ask the code to print this out. Now, once I am done with this vector with the values stored in this vector, I do not want to store them back. So, what I ask the code is again to deallocate the memory. So, in the deallocation process, one should remember that one loses the information which is already stored in there. Now, so often it might happen is that one is interested in sort of accessing the dimensions a certain subset of the array. instead of the whole array at one shot. So, that is also possible in Fortran. So, the syntax typically consists of a comma separated list of index descriptors for each dimension. So, for example, suppose if I have an array which has say 10, 8, 1000. Okay. Now, instead of accessing this whole thing, what I want is to access along this dimension, I want to access the elements which are labeled from 3 to 5, here from 1 to 4 and here from 90 to 100. So, how will I do that? So, I will do it in the following way. So, for each dimension I specify the range. So, 3 to 5, then for the second one 1 to 4 and then the third one 90 to 100. So, when I call this array in this fashion, only the elements which are stored in this range will be accessed. So, this is what is written down here. So, each index descriptor may be say in addition to a single value. So, one can use a colon which returns. So, instead of doing this, you can instead of this, for example, what I can also think of is I want all the 10 elements of this array. So, what I can do is when I call this, I use a colon. I can use a colon and then I say okay, I want only from 1 to 4. So, this will go from 1 to 4 and then say this I say I go for 1000. So, basically what this colon tells is for this particular dimension I want all the elements present there. So, one can also say from a certain somewhere in the middle of the array to the upper bound, one can also want to access those elements, or from the lower bound of the array to a certain particular value I. So, this is done by in this fashion. So, basically what you do is you say in this array. So, suppose I have a one dimensional array variable which I call as array I, and so I say that I within the bracket, instead of writing the total number of elements in that along the dimension, I just write I colon. So, what it and then I do not write anything after the colon. So, what it will do is, so whatever this value I is set to, so from this value to the upper bound of the array, all the elements will be accessed. Similarly, if I write it the other way around here, so I leave the space before the colon empty, I do not write anything here, and after the colon I write I. So, what it will do is it will access the elements from the lowest bound to the ith element depending on the value of I. So, this is how one can access subsets of array. Now, an array, so these arrays which we are dealing in so far, these are typically used for numbers. They are either they can be integers, they can be real numbers, or they can be imaginary numbers. But what happens, or how does one create an array containing characters? So, that is done by this type of arrays called strings. So, string basically by definition is an array of characters, and like the previous cases, the arrays which we saw has dimensions. The length of the array is given by dimensions. In case of string, it is given by the length keyword. Also, there is a requirement for referencing substring, then one uses a colon to access the ith character of the string. One can also use this concatenation operator to link, basically to connect two or more strings together. So, here is an example of a program where one can use these type of string based arrays. So, one way is you define a variable name which is given which you declare as a character type, and you give assign it a dimension of 5, and then you separately save these 5 letters. So, these 5 letters will be saved separately. But suppose if one wants to write this statement or wants to store this statement hello again. So, how does one do that? In that case, one uses this length statement. So, if you look at it, so here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters, 10 alphabets, one space and one exclamatory sign. So, basically to store this whole thing as a single array, as I have done here in this program, in this variable s2, we need the length of this to be 12. So, that is why I have defined it size as length equals to 12. Similarly, you can also in a similar fashion to store this, you need a character array which is length 12. So, this is another way of declaring the size of the character array. So, the thing is that these three stores arrays which contains characters instead of numbers, and these are the three different ways typically people use to assign the dimension. And this is an so what I am doing here in this statement is, so from the S2 array, so I am creating a new array S4 which is assigned the following values. So, from the S2 array, that is from these letters which are written here, I take number 1 to 5. So, basically 1, 2, 3, 4, 5. So, my S4 this stores the following numbers, following letters H, E, L, L, O, and then I connect these elements in the S2 array with the elements of this S3 array. So, what it will happen is, so this and this is through this concatenation operator. So, the remaining so I have here 5 elements, my array S4 can store 30 elements. So, the remaining 25 elements will be used to store this thing. So, if you print out the S4 statement, so what you will find is something like this: hello, what's your name? So, this is how one can connect take a part of one array, another part of a second array, connect together and form a new array. Okay, so, with this we come to an example here. So, which I have given the solution in this slide, but I mean I would encourage you to use it as a practice exercise. So, the idea is, given a set of numbers, you need to write a program which will sort them in an ascending order. So, the algorithm is given briefly here. So, the first you need to read the numbers from given by the user. So, you need to store them in an array, then you need to sort them into an ascending order and then printed out the sorted array. So, this is the program, but I would encourage you to write the program yourself and see how the things work and get a feel of the things. So, with that we are done with the second part of the introduction to Fortran module. Thank you.